Section 1.3, linear equations in two variables, basically deals with what it says. Linear equations, or anything that's going to graph a line. And in the two variables, kind of the standard that we always run into, x and y, two different variables. The simplest form that we've used so far up until this point, and will continue to use, is slope-intercept form, which is y equals mx plus b. And like we've done a lot of already, slope is our m value, the y-intercept, or where it crosses the y-axis, that's our b value. Alright, let's take a look at a couple equations here and how to graph some of these linear equations based on using slope-intercept form. Alright, first one we're going to look at would be an equation like this. Oops, better get you a color you can see. Y equals 2x plus 1. Now, we've done quite a bit with this before, so we'll go through this fairly quickly. Set up our xy axes. And all we really have to deal with here is find the parts. So if we look on this one, there's our slope, which is 2, and there's our y-intercept, which is 1. Remember, y-intercept is always the first thing that we do, slope is always the second. So let's find our y-intercept. Since it's positive 1, we're up at 0, 1. And then from that point, we'll do our slope. Remember, your slope is a rise over run. So a slope of 2 is the same as 2 over 1. So it has a rise of 2 and a run of 1. So we can go up 2 and right 1, up 2 and right 1, and we can reverse it too and go down 2, left 1, down 2, left 1, however far we need to go to get comfortable to draw our graph. Then all we need to do is connect our points. So we take our point here, run it through our y-intercept, connect everything, and we've got our line. So fairly simple. Another form of this, we could run into a constant where you won't necessarily have both the slope and the y-intercept. You may have just the y-intercept, and that might be one that looks like this. Oops, I'm going to change my tool here. So let's say y equals 2. So this actually is taking on the same form, y equals mx plus b. It's just the m value for our slope is 0. So we still got it split up into our slope and our y-intercept. So we're going to set this one up the same way. So we get our axes set up here. And then we'll do our values. So our y-intercept is 2. So we would go up 2, just like we did on the last problem. And then the slope is 0. Now remember, slope of 0, basically, if we set this up as a rise over run, could be 0 over any number for our rise and our run. Basically, it's telling me I could go up nowhere, go right 1. I could go up nowhere, go right 1. I could go up nowhere, right 1. I could go up nowhere, right 5, whatever I need to do. And basically what's going to happen is this is just going to give us our horizontal line. So we can set this one up, we run it through our points, and there we go. So y equals 2 is nothing more than a horizontal line. Now sometimes they're going to set this up with something completely different where it's not in y equals mx plus b form already, or they might give us something like this. X plus y equals 2. Well, all we're going to do is try and isolate the y value. So we can subtract x from both sides, simplify by canceling, and we get y equals negative x plus 2. Now we're set up. On this one, negative x is the same as negative 1x, so pretty much there's our slope of negative 1, and our y-intercept of positive 2. So let's set this one up. So we get our xy axis here. And we'll plot our points. So our y-intercept, just like in the previous couple of problems, has been at 2. So we'll put our point. And again, the slope of negative 1 is the same as negative 1 over 1. So our rise is negative 1, our run is 1. So we go down 1, right 1, down 1, right 1, down 1, right 1. And if I wanted to, I could go up 1, left 1, up 1, left 1, and so on. And then we're ready to graph our line. So we can set up on our point, connect our dots, and just like that, we've got our graph. So, pretty simple. We've worked with this stuff before. Nothing real specific there. Alright, now let's go back to actually finding slope. And finding slope, a couple different ways that we can do this. And the one thing with slope that we want to deal with here is, we always said slope in most of the books has an m for its variable. So a couple things we could do. One would be go right to one of the specific formulas that are shown in a lot of books that look something like this. Y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. All that's saying is if I have two ordered pairs, I can take one of the y's and subtract the other one, take one of the x's, subtract the other one, and now I've got my value. Since all we're doing there is finding the difference of the y's and difference of the x's, some people like to shorten it up, and this is my personal preference. Change in y over change in x. Remember, the triangle means delta, and delta means change. So that's one. If you already have a picture to look at, the obvious one would be rise over run. Let your eyes do the work for you. As you get into some applied problems, rate of change is also a slope. So a lot of different variations of how you can approach finding the slope and some of the different uses for slope. So pretty simple, pretty basic. Let's take a look at an example here. Let's say we have 2 points, points A and point B, and we'll say point A is at 3, 4, and we'll say point B is at 5, 7. Well, if we went right back to our formula that we talked about before, I could set this one up and say there's x sub 1, y sub 1. Only reason I chose those to be sub 1s, they were the first one listed, which would make this x sub 2, y sub 2. So if we went with our formula to find slope there, we could say y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. So just substituting in, y sub 2 is 7, minus y sub 1, which is 4, all over x sub 2, which is 5, minus x sub 1, which is 3. And then simplify. 7 minus 4 is 3, 5 minus 3 is 2, and we've got our slope. Now again, my preference for these, especially if the numbers are fairly friendly, do the same thing, but you can do some of this in your head. So change in y over change in x. So I might go right in order this time and say, alright, let's see the y's. From 4 to 7, what happened? Well, went up 3. The x's, from 3 to 5, well, that went up 2. And a positive divided by a negative is just a positive. and you get the same thing. So again, change and our difference, finding the same thing, just if the numbers are simple enough to use, you can just change or go right to change in y divided by change in x and get things done fairly quickly. All right, we can extend this a little bit with trying to find the slope through 2 points, which is what we just did, but there's a couple special situations that are going to come up. And it's something that we need to take a look at, because a lot of times people will flip-flop these two and kind of get them backwards from each other. So let's look at one situation here where point A is maybe at 3, 5, and point B is at 3, 7. So let's set this one up like we just did, and let's do change in y over change in x. So slope is change in y, change in x. So my y's went from 5 to 7, so they went up 2. My x's went from 3 to 3, so they really didn't go anywhere. Now remember, anytime we have a 0 on the bottom of a fraction, that fraction is undefined. So in that case, it doesn't mean that something's not there. Basically, all that's telling me is when I set this one up on the graph, it's going to be a vertical line. So if we look at this one like this, I can find those 2 points, and I'm going to estimate here so we can kind of picture where they're at. So 3, 5 would be 3 to the right, 5 up. 3, 7 would be 3 to the right, 7 up. So obviously by taking a look at this one, if you were to connect those dots, you get a vertical line. So we go like this. We still say the slope is undefined because it goes up and down, rise and run. The mathematics says 0 on the bottom. Can't happen. So undefined, vertical. Now the one thing that we can look at on this one right away, both point A and point B have the x value of 3, where the y value keeps changing. So the equation of this one just happens to be x equals 3. Doesn't look like y equals mx plus b, yet it's still linear. All right, let's look at another situation that fits under this special type. Let's go point C. Let's start with 3, 5 again. And point D, let's let this one be at negative 1, 5. All right, so let's set up our change in y over change in x again. So the y's from 5 to 5, they don't change, so that's a 0. The x's from 3 to negative 1, they go down 4. Now 0 divided by anything is 0. So this time we actually do have a slope, it just happens that the slope is 0. So let's take a look at what this would look like on a line. So this one on the line, let's set up our xy axis first. Goes like this. Now let's plot those 2 points. So if I go 3, 5, I could go 3 to the right and 5 up. If I went negative 1, 5, I could go 1 to the left and 5 up. And now if I were to connect the lines on those two, I could go right through them. And again, this time it's a horizontal line, which, like you would expect, has a slope of 0. The rise doesn't change throughout the length of the line. Now, just like we did on the last one, the thing that's common is my y values. So this one has an equation of y equals 5. Again, a constant doesn't fit the form y equals mx plus b. It's just the variable and the constant, variable and the constant. But both of these are still linear. So that's 2 of the special types that you deal with on that type of equation. All right, let's take a look at another way of solving these types of problems.